On page 66, we're using that same type of thinking from linear models, and we're extending it and looking at expressions. An algebraic expression represents a calculation that needs to be performed, but it still contains variables. The values of the variables may not yet be known. This example, it's kind of like a laundry example, might seem a little bit silly, but I'm imagining that someone who owns a laundromat might do a calculation like this to try to see what they should charge. And you could, if you wanted to get really into the math of your cost of laundry, you could do this type of calculation. So a washing machine, let's say it cost $400. And then when you're doing laundry, you're also paying for water and for electricity to run the washer. So an estimate might be 75 cents for a load of laundry. You also spend money on detergent. You buy a big thing of detergent and then you use a little bit every time. So these are things you could calculate out. Detergent might just be 15 cents every time you do a load of laundry. My dryer costs $300, and the cost for electricity to dry a load of laundry is 45 cents. So those are all the different costs. Some of those are fixed costs, meaning you pay them once, and some of them are variable costs because you incur those costs every time you run a load of laundry. The variable is X, and it represents how many times you do laundry. The expression for the cost of washing a load of laundry can be written as 400 plus 0.75x. That's your starting cost when you buy the washer, and then that's how much your expenses go up every time you do a load of laundry. 75 cents more, 75 cents more every single time. So you can do the same thing for the cost of detergent and then the cost of drying your laundry. The detergent was 15 cents per load, so this is going to be 0.15 times X. Drying the laundry will be $300 plus 45 cents times X. So notice that, oh, that's weird. I forgot to put the $300 right here. I'll have to fix that. So I did include it down here. These are all the different components. Some of these components are one-time costs, and the other components are variable costs that go up with repeated use. So $700, and then these three terms add up to 1.35x. The process above can be described as combining like terms. So this is my attempt to make up a slightly realistic situation, even though you may have done combining like terms before and there was absolutely no story associated with it. So go ahead and simplify the like terms, the expressions below, by combining like terms. So this is an expression. A couple have separate bank accounts. The expression represents their combined balances after M months. So one person has 175 and their bank account is decreasing. The other person has $220 and their bank account is also decreasing. So to combine these together, take 175 plus 220, $395, and then combine these two together as well. So negative 1.5m and negative 2m. Now we're trying to add negative numbers. Let's try putting that into the calculator. So negative 1.5 plus negative 2 gives me negative 3.5. So the result here was 395 minus 3.5 times m. Since these were both m terms, then this is still negative 3.5 with an m on the back, or times m. So that's me combining like terms in that expression. Here there's no story. So 20 plus 3x plus x, when there's no number on it, it's just a 1x. So 3x plus 1x plus 5x, that's 4, and 5 is 9x. And then there was nothing for the 20 to combine with, or the 6y. And the other thing to note is that these terms can be in any order.